Good evening.
Good evening, sir.
Good evening, class. How are you doing tonight?
Good evening, sir. How is everything?
You know, can't complain. A good day, filled with meetings, but nonetheless a good day. And it's going to end even a fabulous day because I have you. How are you doing, guys?
So you never sound so righteous when you start, yeah, right?
True, true. No, I'm a good man. I'm good. Actually, was up trying to go through some stuff for you. I'm a good man. Good, 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 good.
Okay.
Thanks for asking, though, honey. Good man. I mean, all things considered, it would be nice if I were conducting this class from my hotel room, um, overseeing the night pool and, calling for room service, that could be arranged, but outside of that, I'm good.
Yeah,
All
show
right.
up, yeah, show up,
Sir, your chest just high.
That means we have a shrimp, the shrimp pasta, or whatever you
Mm.
want.
Me should tell you, trust me, man. All right. All right. So what we did last class, we had a look at our piecewise function, and I gave you a question. Oh, before I even go there, so I said to myself, the comment section have good YouTube channel and post something. Only 11 views. Only 11. But I'm going to continue watching and then come back to you guys. One of them has 3 views. So I'm hoping that the ones with the 3 views are the ones that you were present at class for, all of you. And everything is clear as mud. And you don't need to go and revisit the thing. But I trust that you guys are actually going to be looking at those recordings. Okay, so we did our piecewise function, and I gave you, oopsie daisy, I gave you a homework question. How many of you were able to do it?
Sir, I did it, but I left it at work.
It did it, but left it at work. How far is work?
May I have the answers in my head, sir?
Good job. Who else?
I did it, sir.
Good job. So am I to Kelvita? Okay. Yes. There's only 3 people do it. Go ahead, Kelvita. Oh, you're raising a hand to say you did it. Okay, yeah, yeah. So 3 people. Um, Andrew, big boss. You know the teacher homework?
Yes, sir.
You know the teacher homework?
Ah, no, I didn't get a chance to do it, sir.
Okay. Jermaine.
Sir, don't even bother ask Jermaine.
But me notice a trend, from last week. I call him and all. No, him have a common decency to unmute, Look when you tell us to sit out, no? Watch and see. Krishna, how far are you? Okay.
Sir, I wasn't aware that there was an homework, to be honest.
Excuse you. Did you receive the PDF document?
No, I haven't.
Okay, you're not a part of the WhatsApp group then, right?
Yes, sir, I'm a part of it.
No, you're not. Are you sure?
I'm gonna check right now.
Please do. Um, Ramesh, you can't tell me, so you know do my work, Ramesh?
Sir?
You do my work?
Honestly, sir, no.
Ramesh, you know
Ramesh.
do my work? No, man, we can't believe saying the
So I
homework, man.
swear I wasn't aware there was a homework.
No, I can't believe. No, man. That a maximum disrespect. Ramesh, you not do my homework? No, man. Me lose her for you, Ramesh. Lose her for you tonight. Big loss. Sash, you do my homework?
Sir, I just said I left it at work, but
Oh,
I'm
yeah, you did say that. Yeah. I'm sitting on one of my ears. Yeah, you did say that. But you remember your answer, right? Sean Anderson, did you do my homework? All right, so we need to start playing that game now. I need to put that game into action. When I call upon my students and they don't answer me, I just need to give them some time out because I really want you guys to answer me. All right, so I will enact my game. I'm serious. Zidane, did my work?
Sir, I think you need to check your chat.
Oh, sorry. Thank you. What is it from? Sean Anderson. All right, so Davia, did you do my homework?
Yes, sir.
Okay, good. I like that response. And Cherry, did you do my homework?
No, sir, but I wasn't here on Tuesday. I didn't make it to the class because I had internet problems.
Okay. So did you see the PDF document in your WhatsApp at some point?
Yes, sir, I did. I saw it.
Okay. And you looked at it
Yes, sir.
and you scroll to the end of it?
Pardon?
Did you scroll to the end of it?
Yeah, I looked at all of it, sir. But I
Oh,
didn't
so you said that. I thought you said that you weren't aware that we got homework. Okay.
No, I said I wasn't in class because I had internet issues.
Okay. All right. Got you. All right. Thank you. All right. So I was saying to a student on Tuesday that spoke to me after class. And I think I may need to tell you no before you find out. So the pair of us, the class and the teacher, have been living a lie. So behind this microphone, it's a very nice teacher, and I'm not being conceited. I know I'm a very nice teacher. I'm a teacher that is very flexible. I'm a teacher that you can reason with. I'm a teacher that listens. I'm a teacher that understands. But I'm also a teacher that sees black when it comes on to my schoolwork. Now, if you want me to fall out, not do me work when I go now. As I said before, it takes time to prepare the lessons for you. A while ago, somebody said, "Sir, you never sound like you said," because I'm up trying to get myself prepared for my class. So, just as how I can sit up and prepare for you to send you notes, I would expect the only thing you can do to reciprocate the gratitude is to do my work. Now, this week is going to be the last week when I come to class and I ask about my homework and it is not done. I'm going to ask that you make it a point. I don't give you 10 questions. I merely give you one question, merely give you one question. And if push come to shove, I may give you 2 or 3 questions. So the common thing you can do is attempt my work. This is how we're going to conquer Calculus 1. So there is no love lost, because I never told you this side about me. But don't make it happen again. When I give you my work, I expect you to do my work. When you come to class, you ask if sir give work, you look into the stuff. Because, all right, you know what? Before I sin and I lose my seat in heaven, let me continue. When I don't do it again. And I'm asking you, do not do it again. I run my work. I'm going to do my work. I understand that you may have some challenges, but at least try something before class. Now come here, sit down and expect me to sit down and just go through the question and just give it to you. Teach you and then turn around and do the work for you. Now the only reason I'm going to do the question in class is for those few students who said to me, and I know I didn't call upon some students because I know them do them work. Those are the ones that are saving the ones that have not done my work. If you come next class, I won't even tell you what strategies I will take. Please, let us have a fruitful relationship. I love my students. I love my class. I come to my classes always prepared. And that's one of the reasons I come to my class prepared, because I want my students also to be prepared. All right, enough said. Let us continue. Trust that you had a very good day at work today and that you are ready to spend some time with me tonight. Thank you, thank you, thank you. Yes, please, always assume. I'm not going to leave class, students, without giving you something to try on your own. You notice even at the end of my class, I said, no, we have to go start something because I tried to squeeze in something and then I give you to see how well you do it and then we'll start the class here. Last time I said, okay, where we're going. Somebody said, sir, you know, I have two little questions, and I went back over everything just for the class. So I kind of feel, you know, a little way-ish, but I'm grown, I will get over it. All right, so the question was determine if P of X is continuous at X equals 1 and X equals 2. Given that P of X is defined as X squared minus 1 over X minus 1 when X is less than 1, and 5X minus 3 when X is greater than or equals to 1 but less than 2, and 2X plus 3 when X is greater than or equals to 2. So now we need to look at what is happening. So the question says, check to see if the function is continuous. Check to see if the function is continuous at X equals 1. So checking for continuity here. I'm going to be looking at to the left of 1 and to the right of 1. So sir says, since I'm looking at X equals 1 and I'm looking to the X of the left of 1 and the right of 1, anything that has 2 in there, I don't want it because it's one I'm looking at. So the one here I can cross out because I'm not interested in it. The piece right here, so I'm not interested in. So what I have is X less than 1 and X greater than or equals to 1. So I have the left and the right. So to the left of 1 is going to be X squared minus 1 over X minus 1. And to the right, I'm going to have 5X plus minus 3. So let us look to the left. So I'm going to have, this thing is not scrolling. So to the left of 3, I'm going to have the limit as X tends to the left of 1. As X tends to the left of 1. To the left of 1 is going to be where X is less than 1. So I'm going to have X squared minus 1 over X minus 1. And what I'm going to be doing here, if I substitute 1 into the function, I'm going to get 1 squared to be 1, and 1 minus 1 is 1. And 1 minus 1 is rubbishness. 1 minus 1 is 0. And then 1 minus 1 again is going to be 0. So if you look at it here, we can see the indeterminate form coming out to the left of 1. So can you see the indeterminate, the indeterminate form showing up? Yes, please.
Pull up. So when you get sums like this, you have to do the factorization first.
Yeah. Because you finding the stuff, you know. Yeah, man, you finding the stuff. Okay, yeah.
But sir, I thought that we shouldn't factorize in this case.
Yeah,
But
that's why.
I did get 0.
Yeah, me too.
I just
And I
left it
left
at,
it
I left it
there.
at 0. No, man.
Yeah.
Sash, you did not get 0, no, you got 0 over 0.
Was 0,
0,
yeah.
right.
Right. But remember, sir says to you, once it is as an indicator, once it is that you get 0 over 0, it's indeterminate.
Yeah.
So where am I going? So much work we go through. All of them something already, you know.
So something in there preventing it from operating.
From
So
operating.
Say it one more time again. Something in there.
that's
Say it.
causing it not to operate how it should.
Yannick, you're making my evening a little bit better. No, I'm serious. Very nice.
It's a good
So,
thing we read to him, sir.
yeah, man, bless the heart.
It was in question while I was doing it, sir. But
and guess what? I'm happy about that. At least you're thinking about something. So remember now. So once you get 0 over 0, always think the indeterminate form. So Sash, don't say Sarah just got 0. 0 is different from 0 over 0 because 0 over 0 could be 0 over 1 or 0 over 5.
yeah. It's
You see what I'm
actually
saying?
0 over 0, sir.
Right. No, I'm just saying to you, when you say sorry, I got 0, 0 could be 0 over any number, which is still 0.
Right.
Right. And that will change the landscape of what it is that we're talking about. But when you said to me that you get 0 over 0, no, bam, indeterminate. There is something inside the function preventing the true limit of the function to come out.
So, sir, do you have to show the indeterminate first and then do the factorization, or just go straight to the factorization?
Excellent question. So you notice what I have done here, because I would expect you to, where am I? I would expect you to, guys, we have gone through quite a bit of work. John Oster.
Yes, sir. It's page 16 we reached.
Cockroach. No man. Sir, not going to, right? All right. So in order for you to reach this factorization, Kelvita, you have to first recognize that it is of the indeterminate form.
Okay.
So remember what teacher says, teacher says when we're doing the function on a piecewise here, the questions on piecewise, we're not going to be using the intuitive approach. We're going to use the algebraic approach or the calculations method. So what we're going to be doing is assuming that the value of x is equals to 1. So anywhere in the function, I see x, I'm putting 1. But the mere fact that I put 1 in the function and I'm getting 0 over 0 suggests to me that I have an indeterminate form. And if it is indeterminate, no, we have to go doctor it. What do you mean, doctor, sir? Something inside of the function that is preventing the true function from coming out. I have to remove that something in order for me to find the limit. If I don't remove it, there is no way I can tell you whether it is continuous or discontinuous. So I have to do it. So recognizing here that this is the indeterminate form. Sorry, let me just stop share so I can get rid of this thingy bob in front of me here. All right, let me go again now. So having recognized that there is something inside of my something that is causing the something not to come out of the something, I am going to just remove that something. Sir, what are you talking about? I have to factorize. That's what I'm saying. I have to factorize. I've got the indeterminate form. I must do a simplification, a factorization, or a rationalization. All right, so I'm going to do a factorization because I recognize x squared minus 1, so put it up here, difference of 2 squares. So what do you mean by difference of 2 squares? The two something them in the two brackets them are the same. The only difference is that one is positive and one is negative. So that's why we call them the difference of 2 squares, as opposed to being the perfect square. Perfect square means that every single thing in this one would be the same something in that one here. In this other case, everything is the same with the exception of the signs. So x squared minus 1 is the difference of 2 squares. Sir, how do you know that? Because me I look at it and couldn't figure it out. Thank you for asking. So how do you identify the difference of 2 squares? Watch this. Watch my screen. The difference of 2 squares has exactly 2 terms. See here? X squared and 1. It has exactly 2 terms separated by a minus sign. Then, sir, if it was a plus sign, it couldn't be the difference of 2 squares? Absolutely not. So this is how you identify the difference of 2 squares. Watch me. The first term is a perfect squares. The last term is also a perfect squares and separated by a minus sign. So it has 2 terms exactly separated by a minus sign. The first term is a perfect squared, so is the last term. Sir, how you get one to be a perfect squared? A perfect squared is that number. When you multiply it by itself, you get back that number. So I can say to you that 4 is a perfect square. Sir, how do you know that? Because when I multiply 2 by 2, I get 4. Oh, then sir, what if I multiply -2 by -2? I still get 4. Oh, sir, so that's why I call it a perfect square. Yeah. So 1 times 1 is 1. Is this one? So I'm breaking up this number into 2 numbers. And when I multiply together, I'm going to get the same number here. Then, sir, you show me how you do x squared to get that as a perfect square. Simple. X times x is x squared. Now watch it. Magic. X squared is this one x multiplied by this other x to give me the x squared. Oh, then sir, how do one come in now? This one, I'll go be the 1 here times the 1 here. So I'm going to see that because it's a -1. Very good. When I'm multiplying a -1 by a +1, I get back a -1. So this is a nice grown-up way of factorizing the difference of 2 squares. Exactly 2 terms, separated by a minus sign. The first term is a perfect square, so is the last term. You're going to have the same thing inside here in both brackets, except that you're going to have a minus sign for one and a plus sign for one. So I have one final question. Shoot. Then suppose me to write x plus 1 first, sir, and then x minus 1 after. Would it be the same thing? Absolutely. And thank you for asking. It doesn't matter which of them I put first. I could put x plus 1 first or x minus 1. It doesn't matter. As long as I have the x minus 1 and the x plus 1. Got you, sir. All right. Now, I have no isolated or what was causing my problem. Then, sir, how you know says the x minus 1 causing a problem? Watch this magic. If I put 1 in the something, you will get 1 minus 1, a 0. That means we can't have 0 in the denominator. There is no time at all that I can have a 0 existing in the denominator. It doesn't work. Nada. All right? So therefore, I knew that this x minus 1 was a problem. So therefore, when I cancel my x minus 1, I'm only left with x plus 1. So now it is I'm going to substitute my 1 into the x plus 1. 1 plus 1 is 2. So that limit actually tends to 2. From the left. Sir, how you know it's from the left again? See the superscript minus sign here? Oh, yes, sir. Thanks. And then I'm going to do to the right. And how I know it's the right? Because I have the plus sign. So let's go. I'm looking at x greater than or equal to 1. So my 5x minus 3 is to the right. Anywhere in the function I see x, I'm going to put 1. 5 times 1 is 5. 5 minus 3 is 2. Oh, yes, sir. I see it now, sir. So since the limit from the left is equal to the limit from the right, then the function is going to be continuous at x equals 1. Pressing pause. Is there anybody in the class that don't understand this?
Sir, explain about the negative and positive part.
Explain the negative and positive part? Okay, no problem. Thanks for asking.
Plus 1.
Yeah, thanks for asking. Nestor, can you Yes, Krishna, I got you. Do you have another question, Krishna, or that's the only question?
That's it.
Okay, Nestor, can you unmute for me, honey? Nestor Boo. All right. You heard Krishna's question, Nestor?
No, sir.
No? All right. You sound like you're asleep. You can mute. Onika, can you unmute for me, please?
I have a remote beside you. Hi, sir.
Oh, how you doing? You good?
I'm quite fine.
Nice. I'm happy. You sound very chirpy. You heard the question that Krishna just asked?
Somewhat. I think he
Okay.
asked, but I don't know exactly which negative he's referring to.
Can I show you?
Go ahead.
Right here, so. And right here, so. You can tell him why for me, please?
No problem.
Okay.
So, okay. So the reason why it's negative because the negative one represents which side we're doing. So it's left, meaning greater than. So go back to the greater than.
Meaning?
Sorry, I mean lesser than. My
Thank you,
apologies.
please. Go
Sir,
ahead.
go back to the lesser than so you see. You're not
Okay.
showing it now.
I'm not showing it. Hold on.
So it was the difference of two squares one I was talking about, but
Oh, sorry, not this
Yes,
one
sir.
here.
yes.
Okay, my bad.
Exactly, sir.
Okay,
But
okay. So
it's
say it again, Krishna.
related, I think.
No. It's unrelated.
Okay.
But Anika, hold on, Anika. I like how you explaining this stuff. So just finish the explanation, Anika. Thanks.
No problem, sir. So yes, so it's so because the negative mean that we're doing on the left side. Once we see a greater than, a lesser than, my apologies. When we see the lesser than, it mean we're doing on the left. So it's LL, and then we just put minus represent left side. Then the plus would have mean that we're going to greater than, and with the plus, which we would normally do, instead of putting right side, we put plus now beside the number to represent that we're doing the right side.
Again by your sweetie here. Very nice. Very nice. No, I'm very happy for that explanation. It says to me that you heard me. Yes, please.
time now, sir.
No, sir, I have a straight link up. I don't even know if I put on a phone here by now. All right, very good though, Anika. And you know why I asked you to continue? Because I know there is somebody in the class who never get that explanation very well. And that's why I wanted to do that. And that's my strategy, students. So I will call upon you not to embarrass you. That's not my aim. This is a family. And you know, if you think back at your own family, sometimes you may get boof or you may cause the boof. But it doesn't mean that your family member does not love you. And it's like I'm cussing out today. I don't love him any less, you know. But I'm just saying, I have to make my point because I really want the best of you. So I have to tell you when I'm pleased and when I'm not pleased. So when I call upon you, I want to know what it is that you know. So Nico, very good. I'm going to buy you. You know what paradise plum is? You're a young fool. You don't know what paradise plum is. I'm going to buy a paradise plum so you can get the real Jamaican taste out of that. Very good. All right, Krishna.
Yes, sir. Before you proceed, I have one
Sir, where you
question,
go
though.
buy fine paradise?
We don't know. Yes, Nico.
Yeah, sir. So each time I see the negative, the x squared minus 1, it means difference of 2 squared, and I put the x minus 1 and the x plus 1.
Very good. But I can also give you other types of the difference of two squares. All right. So let me just see if I can, instead of wasting time to.
But yes, sir, that's what I was talking about, the difference of two square.
Yeah, man. I got you, Papa. Got you now. I'm saying instead of wasting time to try and type it, let me see if I have in my repertoire other examples that I can just copy and just fling into the something so it is spend a little less time. No. I just confused the computer. Yeah, I can have a read only. All right, good. Listen, no. All right, so I'm just looking for examples of the difference of two squares. Actually looking to my FCM1 notes. To see if I can, this one. This one's a perfect squares. So, okay, so let me just put a perfect squares example here so at least you can copy. And then let me put this. I actually thought of something, you know, and I mean, the question that Krishna just asked a while ago now has brought it to the fore, and that's why I'm going all the way up here.
Sir, you have one perfect square up in a list, you know.
Yeah, man, yeah. But let me tell you what came to mind. The other day I was reflecting on the class that there are some prerequisite that you must know before I move into some other areas, and that's exactly what I'm going to call it. So I'm going to call it prerequisite, and I'm going to put here. So for example, this is a perfect squares. So I have my perfect square here. Let me go back. Bear on with me. So that I can find the difference of two squares in this thing. Oh crap. Don't do this thing anymore. You know what I could do? Let me see what I could do. I can use that very example that I did. X plus 4, X plus 5, no. Maybe I would have gotten through if I had those. All right, I'm going to use that very example I have there, Krishna, to work to show you the difference between the perfect squares and the difference of squares. All right, so let me go back to 4 notes. All right, so the prerequisite here, and I'm going to call it factorization, F-A-C-T-O-R-I-Z-A-T-I-O-N. All right, F-A-C-T-O-R-I-Z-A-T-I-O-N. All right, so the prerequisite is going to be factorization. I'm looking at perfect squares. So let me amend it to an expression rather than being an equation by removing my equal signs. Yeah. So, oh, Rockstone, you know what I need to do? Did I give you a write-up to show you how to factorize, multiply the coefficient of x squared by the constant? Did I do that with you at some point? Yeah, right here.
Yes, sir. Yeah, the first class I'm coming.
Right. So factorize a quadratic expression. Factorize a quadratic expression. All right, so I'm telling you to just look up top. Since I've already written it there, I don't need to write it again. All right, so I'm multiplying the coefficient of x squared, which is 1 by the constant. So 1 times 1 is 1. And I need two numbers. When multiplied together will give me 1, but when added will give me the middle number. So it's only only one set of numbers we can do, 1 and 1, because 1 times 1 is this 1. I'm going to add 1 to 1, I get 2. So my factors are 1 and 1. Factors 1 and 1. So my factors are 1 and 1. So I am breaking up this 2x into two terms, 1x and another 1x. Sir, but you just say 1 and 1, hee. But remember, now we want a 2x. So this technically now has to be 1x and 1x, which is here. But sir, I don't see the 1. I don't have to write the 1. You know, we can just simply write x. And then now I'm going to be grouping. So when I group, I'm going to put two terms in one bracket and the other two terms in another bracket. And incidentally, that's why I had to break it up, because I had only 3 terms. You know, this is sometimes called a trinomial. Tri means 3, 1, 2, 3 terms. It is sometimes also called a quadratic expression because the highest power here is raised to 2. All right. So I'm putting these two terms in one bracket right here. So x squared plus x in one bracket. I'm leaving out the middle sign every time we do the stuff. And then I'm going to put my x plus 1 in another bracket. Then I'm going to ask myself a question. What is common here that is common there? And your response to me should be, sir, x. Then I'll say, very good. And then I'll say, what is left? And when you take an x out of x squared, you're going to have an x left. And when you take an x from this one, you're going to have just 1. Excellent. What is common here that is common there? Sir, nothing. Not true. 1 is a factor of all the numbers. Everything, 1 is a factor of it, eh? So you're going to take out 1. So it's going to be 1 times x is this x, and 1 times 1 gives me this 1. So when I look here, I'm going to see what is now common. And you will say, sir, x plus 1 is common to here, and x plus 1 is common to there. So I'm taking out my x plus 1. And then what is left is going to be this x, and what is left on this other side, going to be plus 1. So I recognize that I have my x plus 1 times x plus 1. So this is now called a perfect square. It's now called a perfect square. So why? It is called a perfect square because I have x plus 1 times x plus 1. Now that x plus 1 times x plus 1 can simply be written as x plus 1 all squares. X plus 1, 2, bam, 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 bam. I can simply write it as my x plus 1 squared. So why again? Because I end up with two of these things. Both of them are the same. And remember, the law of indices from what it is that we did briefly. This x plus 1 is raised to the first power. This x plus 1 is also raised to the first power. And the law of indices says, when I'm multiplying and the bases are the same, what is the base, sir? X plus 1 and x plus 1, I add my powers. So I put back the base, x plus 1, and I add my powers. 1 plus 1 gives me 2. All right? So that's an example of a perfect square. Now let us look at an example of the difference of squares. Any questions so far?
Sir?
That's good.
Before we get any further,
Go ahead.
I was going through one of the past papers. Maybe I might have been getting it wrong. But I saw one of the questions. It said 2x squared minus x minus 15. So I was trying to factorize to figure out which numbers would add together to get x, but still multiply to get 15. That is what? 3 and 5 and 1. No. And what can multiply to get 15 is 3 and 5 and 1 and 15. Right. So I had done the calculations and and it came out to be indeterminate. We got 0 over 0.
All right, don't go any further, because I hear you using indeterminate with the factorization, and I want to make sure that you are saying the right thing. You just said something about it, and I wanted to do. Okay, I know why I stopped share. You have to see the teacher here. I know why I stopped share. No. So this is why it becomes very important,
right,
for you to talk to me in class, because what it does for me, it gives me an opportunity to clear up any misconceptions. So let us see how best I can do something here now. Oh, sorry, I don't need to reshare, right? Smart. All right, so I'm now resharing, and all right. That sounded like Andrew a while ago. Am I correct?
Oh, yes, sir.
All right, go ahead. No, hold on, Papa. Hold on.
With the question itself?
Yeah, man. You said 2x squared something.
Okay, it's the. Hold a moment for me, please.
Trying about a beta or no? Or pincher.
Sir, I think the question was 2x squared minus x minus 15.
All right, thank you, Juan. All right, okay.
Oh,
so
that was
2x.
that. Yeah, that's it.
Okay.
But wasn't the full question. It wasn't really the full question.
But you had right. But got
Yeah.
you. But you have to factorize this portion. All right. So just allow me to just work through this portion with you to help you with the factorization. Now,
Okay.
remember what Sir says. You're going to be multiplying the coefficient of x squared by the constant. The coefficient of x squared by the constant. So you're going to be multiplying 2 times negative 15. And 2 times negative 15 is negative 30. I am going to forget about this just for a moment, and just work with this 30. So what I'm saying here now, I need two numbers. When multiplied together will give me negative 30, but when added will give me a negative 1, right in here. So I'm forgetting about this negative 30 for a moment, and prime factorizing my 30. Watch me. Prime factorizing means that I'm using prime numbers. 2 into 30 goes 15 times. 2 can't go into 15 as a factor. So I'm going to leave a remainder. So I'm going to jump to the next prime number, which is 3. And 3 into 15 goes 5. But the story gets nicer because I can't use 3 anymore. 4 is not a prime number, so the next prime number is 5. And it so happens that it works out to be nice. What I must do now, what I now must do, is to manipulate my prime factors. I must now manipulate my prime factors in order for me to find those pair of numbers that when multiplied together will give me negative 30 and when added will give me a negative 1. So watch me. I'm going to say 2 times 3 is 6 and the 5 is going to stay by itself. So 6 and 5. Oh, but sir, 6 times 7 are 30 for true. Yeah, man. And then I need a negative 1. Remember, there's a negative 1 I need. So it means that the bigger number is supposed to be negative. All right, we could check it now. Negative 6 times positive 5 is negative 30, which is what we want. Check. And when I add negative 6 to positive 5, the story says when I'm adding and the signs are different, I subtract the smaller number from the bigger number and put back the sign of the bigger number. So which is the bigger number, sir? 6. That means that the answer is going to be, when I do this, the answer is going to be negative because 6 is a bigger number. And then it says, take the smaller number from the bigger number. So we take 5 from 6, and we're going to have 1. So the answer is negative 1. So right here and then, it fits the criteria that I'm looking for. When I multiply them together, I'm going to get negative 30. And when I add them together, I'm going to get negative 1. So what I'm going to be doing here is to say 2x squared minus 6x plus 5x minus 15. Then I'm going to go to say 2x squared minus 6x in one bracket. Every single time I shall leave out the middle sign, and I'm going to say 5x minus 15. Then I'm asking myself the question, what is common here that is common there? What is common, class?
2.
2x.
2x. So 2x is common. What is left?
X
And
X
Minus
minus 6.
minus 3.
3.
minus 3. Very good. Now, what is common here that is common there?
5.
5.
And what is left?
Minus
X
5.
X minus
minus
Sorry,
3.
And what is common here that is common there?
X minus 3.
And what is left is going to be?
2x plus 5.
And that's the answer. So that's how we'll go about doing it, Andrew. I know the question may have other areas because it sounds like it's a question on limits that you're doing or something like that, and you get the indeterminate form. And so I can tell you based on what it is, Andrew, that I'm seeing the question and how we write the questions. Chances are in the denominator you had the x minus 3. True or false?
Sorry, you know, so that method.
Yeah, positive. It was a positive 3.
You had an x plus 3 in the denominator?
Yeah.
Yeah.
Yes.
Well, it couldn't, if you had an x plus 3 in the denominator, it wouldn't be indeterminate then. X was going to what number? X was going to positive 3 or negative 3?
X was going to positive 3, but there's also a separate function underneath it as well. Because I didn't tell you everything, but there is also
the question, sir, the question is you're finding the limit as x tend to 3. The equation is 2x squared minus x minus 15 over 3x squared minus 4x minus 15.
Sir, before you go any further, you can just explain about the prime number, the table thing, sir, because me that try. Actually, do you get the 6 and the 5 now, sir, but me do it a longer way.
It was minus 15, not plus 15. Minus
Here, don't it, in the denominator, this one?
Right, yes.
Sir, minus 15.
Okay. I hear you're trying to chime in. 1 minute, please. X tends to how much number?
3.
Positive 3?
positive 3.
Okay, all right, fine. So we do the numerator one. So we'll get indeterminate here, so right?
Yeah, that's correct.
Okay, all right, no problem. This will finish your question. Go ahead now, other student. Who is this?
Oh, I mean, did I ask about the table thing that you use, sir, with the 2, the 3, and the 5? Because I got the 6 and the 5, but I did it a longer way. Basically, how me did learn it, you find everything like, for example, 2 times 15 give you 30, 3 times 10 give you 30, and then you continue go down and then you reach. You write them back and forth, and then based off of that, you work it out. But that way that you used a while ago, it look a bit easier.
I'm telling you, this is the mathematical way to do it. I'm going to tell you the truth. You know, when I was going to local school, I saw them tell me, you know, I have to sit down and write it. But sometimes the truth is, when you are working, I can give you questions where the product is going to be 180. Now, who you think will sit down and try to find the factors of 180? We don't have time for that.
Sir, it might mix up HCF with LCM.
No man, he's correct. I'm going to show. Let me just project
have a long way in it.
Yeah, let me just project my
HCF you talk about.
No man,
it's not HCF. I know exactly what he's talking about. Let me just share new share and see if I can find one of those questions. So these are some questions I had for my foundation 1 students. So it may so for example, when I multiply 12 by 35, I get enough. Who do you think will sit down? What multiply 12 by 35 and what it gets?
$420.
Who do you think now I will try to find factors of 420? When multiplied together give you 420, but when added give you 1. Me don't have time for that. Me moving to the next question. Me don't have time for that. So Lexon is correct in that he would have to sit down and say 420. So it's going to be 210 times 2. Then that is way too long. Prime factorizing this 420, boom, bam, you get your 21 and 20 as your factors, right? So prime factorization is really the way to go. Is really the way to go. I don't expect them to give you anything like this, like 12m squares and 35 to do that. Don't expect them to do that, to give you that. But to stop them. They can very well give you something like that, right? And if you're factorizing something like this, 12m squared plus 99, who is going to sit down and figure out all of that? Prime factorize. 8 times 91, big numbers. 12 times 56, big numbers. 70 times 5, big numbers. 40 times 60 to factorize, big numbers. I don't have time for that. So prime factor, 36 times 25. So prime factorization is really the way to go. Is really the way to go. All right.
Sir, you can go back, please. I can take a picture of that.
Of what? Of the screen that I'm on now?
No, not that one. The one before where we were writing.
Oh yeah. I was about to stop share right here. Oh crap. I never needed to stop share. I just needed to create a new share. All right. So yeah. So that's what it is that we do right here. Let me know when you finish, sweetie, so I can just move on.
Good to go.
All right, let's go. All right, so yes, please. Somebody says, sir, yeah.
How you get the 3 in the first bracket?
3?
Yeah.
I said to myself, how many times can 2x? How many times can 2x go into 6x? What's your story? 6x divided by 2x. The x then cut off. This into that was 1 time. This into that was 3 times. Magic equals 3.
Okay.
That's how it is that we do it. All right. All right. Since I want to close out this document, allow me to factorize the 3x squared, the 3x squared portion now. Allow me to factorize 3x squared minus 4x minus 15. Again, I'm going to multiply the coefficient of x squared by the constant. So 3 times negative 15 is equal to negative 45. Negative 45. I need two numbers. When multiplied together will give me negative 45. But when added will give me a negative 4. I am going to try and factorize. 45. Bam. Prime numbers only. 2 is the first prime number. It can go into this exactly. So I'm going to try 3. 3 into this goes 3 once, 3 goes 15 times. I can try 3 again. 3 into this goes 3, 5, 15. Go. Count the 3, so the next one is going to be 5. Bam. So I see it right there because 3 times 3 is 9. And 9 and 5 is 45. And when I subtract 5 from 9, I'm going to get 4. So my factors are negative 9 because I want the bigger one to be negative. So it's negative 9 times 5. So I'm going to have 3x squared minus 9x plus 5x minus 15. I'm going to group. And when I group, I'm going to have 3x squared minus 9x in one bracket. Leave the middle sign out every single time. 5x minus 15. Then I ask myself the very question. What is common between 3x squared and the 9x? And your answer to me is?
3x.
Very good. So it's going to be 3x. And what is left?
X.
Minus 3.
Minus 3.
Very good. And then now, what is common between here and here?
5.
And what is left?
5.
Minus
And
3.
x minus 3.
Good job. And what is now common between here and there?
X minus 3.
Excellent. X minus 3 times 3x plus 5. All right. So now I can rewrite my question. I can rewrite the question given as, which one up to some now? As x minus 3 over 2x plus 5. X minus 3 over 2x plus 5. All right, try this. X minus 3. What am I saying? 2x plus 5?
Yes,
2x plus 5 all over x minus 3 and 3x plus 5. And this is the limit as x tends to 3. All right. Now, we will know that it tends to, it will be indeterminate because 3 minus 3 is 0. And this 0 times this is going to give me 0. And 3 minus that is going to be 0. And that time that's going to give me 0. So I notice it's indeterminate. But having factorized, I recognize I can get rid of my indeterminate form. So I can get rid of this and I can get rid of that. So the question is now left with 2x plus 5 over 3x plus 5. And I'm going to assume x to be equal to 3. So what I'm going to have here is 2 times 3 plus 5 over 3 times 3 plus 5. 2 times 3 is 6 and 5 11. And 3 and 3 is 9 and 5 is going to be 14. So my answer is going to be 11 14.
Sir, I realize we're going with them question, you know. With a bite of more than
You can true?
Yeah, what I've gone and try.
But hold on. You know some people who have gum bite hotter than people who have teeth? All right. And I did not mean anything. Anyway, move on. Go ahead.
Yeah, so being that it's 11 over 14, could you break it down to say equal?
Remember, the 11 is in the numerator now. So it's a proper fraction. So I can't break it down any further. That's a proper fraction.
Okay.
Sir.
Here, Paul.
Yes, to get the full marks for this question, because it's 5, we were to do the calculations first to get the indeterminate form of it and then factorize afterwards.
Yes, sir. And please do not tell me that, sir, so much work for 5 minutes. This is big school mathematics.
Sir, so once we see 3 numbers in the denominator and it's an indeterminate, we got the indeterminate form. We must factorize both sides of the line.
Yeah, man. Oh. So if this is a question here, and they said to find the limit, yeah, man. We're going to get, once we put x equal 3 into the function, you're going to get indeterminate. Remember, when you get indeterminate, you can't leave it there. You must say to yourself, there is something inside a function preventing the true limit from coming out. You now need to find that something.
No, sir. Remember, we've been working with two numbers in the denominator.
Denominator, right.
So the 2017 paper full of 3 numbers.
Don't worry about it. And that's why tonight's class is going to be some questions that we're working. So tonight, that's what I was doing earlier today, because I'm finished with unit 1. I am finished, but I know some people don't finish with me. So yes, honey.
Scroll down to the question part, sir.
Yes, not this one.
Sir says really that did not go on. We did only a factorize the top.
The top one, yeah, man.
This no make no sense. Well,
Yeah,
keep look alike.
Right. Very good. So you see, where I say to you that I'm teaching you conceptually, because having looked at it, I used to say nothing not go on because it can't factor something. You know that the question is incomplete. You know the question is incomplete, and there's something else that you have to do.
So last part now.
I'm not lie, that little table thing there, are the key that, sir. So if me did know that, sir, because weekend when me I work it, sir, the long boring way me go till night start to hurt me, sir. And when you do it that way, then I say, really?
Sir, big up yourself, sir. Big up yourself.
Yes.
Sorry, I might need to.
Say that again? No, man, I'm hearing you, man. I'm hearing you. I'm hearing you loud and clear. Yeah, man. And so again, let me just reiterate the point. So one, I commend you for going into the past papers, because it's from last Tuesday. Andrew wanted to ask this question, and I'm figuring, because I remember him saying that he wanted to ask something. And also, I really hope that those of you who don't start looking to the past paper, you feel really, 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 really bad. Yeah, man, because at this point in time, now we need to start looking in the past papers on anything that says limits and piecewise. Don't look on nothing else. Just look to the paper and say, yeah, man, I want to look like one limits and I want to look like one piecewise. And we're going to attack those. That's what we're going to be focusing on in class tonight. And also,
so when you finish and then we go to the past paper.
No, man.
Stop till we can chew with the little baby teeth.
Yeah.
We go tackle that.
Yeah.
See, then nearly choke, sir.
No, but you see, the truth of the matter is, I think you're the one who said that when you factorize a numerator, you look on the something and say, but it not key because nothing can cancel the denominator, which is a very good analysis of it. Because at that point in time, now you said to yourself, say, we now so don't know we can cancel. So clearly something else is missing, and we need to do something more. So what it is that
what I actually said is clearly this is sir problem to explain.
Unique, I thought you were my friend, but no, man, and I like it. And it again now gave me an opportunity now to clear up something for Lexton, for him to have a better understanding. As a matter of fact, I think for all of you, because the way Lexton was doing the stuff is the very way that I was taught. And when I started teaching, I said, oh, hell no. There is no way I'm going to take this method to the class. Somebody have to come up with something else. And this is the end result of it. It is much easier. I tell you, you can prime factorize 2050 and get your prime factors easy than going to sit down and write them out. You know, time for that. One of the things that I really want you guys to do. I was never a lazy student, but what I don't do is I don't work hard. I work very smart. So if I am doing some stuff and I know opposites, if you never study the something and its opposite, oh hell no. Never study the something. And then in my headspace now I know what I can use that something and find the opposite of it. All right. So at least I have less thing, to cram my head with. And it worked. It worked beautifully for me. And guess what? When I move into things like differentiation, you see exactly what it is that I'm talking about. And when I move from differentiation into integration, you will see even further what it is that I'm talking about. All right. So having done that, you will see that your answer, one of the things that I like about this question is that you didn't get a rounded answer like 3 and 5 and 8, or even -2 on them number there, then you get fraction. All right. So this is the limit. Can't go no more than that one here. All right. So new share. I'm going to go back to my document, and I'm going to. So that's a perfect square. I now need to x squared minus 1. Let me just copy this. As I told you, I'm not lazy. I work smart. I'm not going to sit and type over that. I'm going to type into it. So the other question was x squared minus 1. Now, when I'm showing you the factorization like this, one of the things that I'm going to be doing is putting a placeholder. One of the things that I'll be doing is putting a placeholder, and my placeholder is going to be my 0x. Sir, why do that? I really want to show you how the factorization that I showed you just now, multiply the coefficient of x squared by the constant, is standard. That's how I expect you to factorize any question. Having done a few of those factorizations, then you will see, you'll observe some stuff like, oh, the difference of 2 squared now has only 2 terms. The first term being a perfect square, the last term being a perfect square, and separated by a minus sign. So this is how I was able to come up with something like that. So what I just told you in that story a while ago is nothing that I saw in a textbook. It's something that I would have seen, and I just, talk it over and over. So it sounds like a nice little story. Watch me. I'm multiplying the coefficient of x squared by the constant. 1 times 1 is 1. Oh, sorry, I have a -1. Yeah, I know we have a -1. So here's my story. I need 2 numbers. When multiplied together will give me -1, but when added will give me 0. Oh, sir, but if you want a negative number, sir, one of the something must be positive and the other something must be negative. A
-1 plus 1.
Very good. Excellent. 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 So one is going to be -1. One is going to be +1. All right. Now, so having done that, I'm now going to be writing my stuff into x minus 1 and just changing it up like that. Sorry, there's a break in transmission because I am actually typing as I go along. So I'll be finishing a few. All right, there you go. So I am substituting my +1 and -1 into the function. See it right here, sir? So I'm replacing my 0 now to that. So you see why I put this placeholder? And let me put it there. And I will put a notation. So you teach a nice know, I will put a notation because I want you to recognize what is happening. We'll place of TLACEHOLDR. Ouch. I'm putting a placeholder there. But I want you to recognize that it's a placeholder. And you'll see, oh, come on, no. You'll see why I call it a placeholder. See it right here, sir? You'll see why I call it a placeholder. Because you can move from 1 2 terms. Copy. Paste. Fix the one here. Take out that. So you're moving from 2 terms, right? You're moving from 2 terms. Them 2 terms are. And then sir, to put in a term inside your sister. Why are you putting a term inside your sister? Because you will understand better based on what it is that we did before, that you're factorizing. And in the factorization that you're going to have, because there is no middle term with the x here, it means that it's going to be 0x. You put in this placeholder because when you look at this point here, which is where I want to talk about, you can have -x plus x will give you a 0, right? So this placeholder really tells me down that there are supposed to be 2 numbers inside here. When added will give it a 0, which is this. If I never put this here, you say, sir, oh, this come in here, so right here, so. But now that I have a placeholder, You can see what is happening now. The story continues. I'm grouping. So put them first two in the bracket, leave out the middle sign right or so. Let me go to my spotlight so you can see. Put them first two in the bracket, right or so. The middle sign here so gets left out every single time. Gets left out every single time. Gets left out every single time. And then I'm going to have this x minus 1 in the second bracket here, which is this. All right? Now, what is common here that is common there? It's going to be x. What is left? X minus 1. What is common here that is common there? 1, sir. Yeah, man. What is left? X minus 1. Be reminded that anything that is inside these parentheses must be the same something inside these parentheses. Watch the story as it develops. Come on, computer. See yourself? Anything inside of this bracket right here, so must be the same thing inside of the other bracket right here, so right? And that's how you're going to be able to factor it out. And then when I factor out, I don't know what number is that, so let me just change it, x minus. And when I factor it out, I'm going to get the x minus 1 times the x plus 1, and then that will be my answer. All right? So the prerequisite for this, for the piecewise function, really is going to involve a lot of factorization. Now, you see the point I was making earlier on Tuesday with you, that, oh dear, piecewise function. Example 1 is that now is every time I come to class, I disturb the notes, because when questions are asked, I have to put things in there so that, you know, when you're looking at it on your own, it should be able to be self-explanatory. All right. So I'm just saying this again to say to you that when I say to you that I'm finished with the document, it means that you can go ahead now and print and put up, because it means that you're not add nothing more to it. All right. So let's go. So now, so having done this now, we'll cancel out, and yeah, we did that and we got our x equals 2. So I'm asking if you can see the indeterminate form showing up, and the answer should be yes, right up here. So and then we can say, since the limit to the left is equal to the limit to the right, then p of x is continuous at x equals 1. And similarly, we don't need to look at the function to see what happens at x equals 2. At x equals 2, we need to look to the left and the right of x equals 2. Looking to the left of x equals 2 is going to be C. We're forgetting about this piece here now, you know. And then we're just going to concentrate on x is less than 2. So x less than, as Anika said, less than is to the left. The L and the L, no, not Yanika. Yeah, either Yanika or Anika, one of the two, says less than is to the left, because the L and the L, very good. We are studying smart and not hard. So we know that this one is going to be to the left, and this is x is greater than or equals to 2. So because it's greater than, it's going to be to the right. All right. So we know to the left is going to be 5x minus 3, to the right is 2x plus 3. To the left is 5x minus 3, to the right is 2x plus 3. And then anywhere in the function I see x, I'm substituting 2. 5 times 2 is 10, minus 3 is 7. 2 times 2 is 4, plus 3 is 7. Whoa, sir, the two of them continuous. Very good. So since them 1 year is equals to them 1 year is equals to them 1 year, it is continuous at x equals 2. Fair enough? And this is where I reach. Say it again. All right, good. Let me see if I can do a new share. Lord, I don't have it. That's what you're saying, Jesus. All right, I was working on a document. All right, so clearly I have to use it from here. Let me just see this one here. All right, so I was looking at the 2017 paper, and I was trying to get some questions done up for you. All right. No problems again.
Sorry, going to do sketching also.
Say it again.
You were supposed to be doing sketching today as well.
Yeah, man. Supposed to do sketching today. I remember that, but I want us to get a little bit more into the piecewise first before I jump into the sketching part. But I remember that. Thanks for reminding me, hon. So when I look at question 3, and I'm saying to myself, wow, for 30 marks, this is a beautiful question. You get 3 questions. Rockstone, another same question this. Yes. These are the paper that we were looking on.
That's right.
Yeah, the paper that's in all look fun, yeah, man.
Yes, sir, that paper.
Right. I didn't even recognize, because I really wasn't looking at the limits question per se. I was more interested in this one. So really and truly, these questions are not difficult. What I will do, I'm hoping that I will be able to do and type these questions up so I can send off to you. But trust me, it takes a bit of time, and I have so many meetings. Oh Lord, help me. But anyhow, and then this one here is what it is that I want us to look at tonight. Now, it says a function f is defined as this. It says determine the values of a and b such that f of x is continuous over the interval negative infinity to positive infinity. Jesus have mercy, sir. You move from 1 and -1 and the other top of infinity and negative infinity. What it is saying to you is that it's going to be continuous at every point. Because if you move from negative infinity to positive infinity, you don't have nowhere else to go. It means that you take into consideration all of the numbers then. All right? So what I'm saying to you here, where the question says, if f is continuous over the interval negative infinity to positive infinity, it means you're going to look on them something here. You see the question here? Are the same question we have been working on over a period. And at 10 marks written on the same question. Is only that we not have the middle something here. So what I want you to do is to do the same thing. You look into the left and the right of the limit of -1, the left and the right of the limit, +1, and you are going to find out the value of a and the value of b for me. That will make this function continuous at every point. So do the question. Say it again, Calvita.
First, never set a question wicked.
No, man.
That was the question that made me say, sir, trouble this.
No, 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 man. Give it a try. I'm gonna give you about 5 minutes to give it a try. All right, I give it 10 minutes. I want all of it tonight. Tonight I'm spending some time doing some questions. All right, on the past papers. So I'm gonna give it 10 minutes. Yes, honey.
I was gonna say I saw this on Edit and Edit Start.
Absolutely. All right, so I'm gonna give you 10 minutes to try. The 10 minutes is not for you to go hold a 10-minute sleep. It is to try the question. Wherever you are, that's fine after 10 minutes. I'm going to.
Which question was
Part B. All right. I'm gonna refresh myself in the interim, but go ahead, please. Part B. I am gonna work the question myself. All right, start. On the mark, get it, go.
Sir, me get my answer. If you answer right.
What you got for the first part of the answer?
Sir, I say A and B would be 2 and 10.
All right. Right.
So I'm wrong strong.
I love the energy. I love the energy. I'm coming to you. I'm still working. What of that? How are the others doing? I hear one answer so far, which is commendable.
Sir,
What?
try it.
I'm confused, sir.
You're
Try it.
confused.
Yes, sir.
All right, no problem.
I
All right, no problem.
we're confident about it.
All right, let me just finish this thought, and then I will. Let me just finish this thought to give you a little jump start. All right, so let me, so work with me. I'm doing, I did the first part, and then I'm gonna allow you to do the second part of it stuff. All right, watch me. Now remember, what I did here was to copy. I don't need to put this piece in here. So
Sir, we are sure, not sure.
okay, my bad. Let me just do share. Put a buff. Okay. So what I did was also copy the question that I did before into what it is that I'm now doing. So watch me. I didn't even finish typing the question, but you know what the question is. At x equals -1, to the left of -1 is going to be the function 2x squared minus 4x plus 2. What I would have shown you in a previous class is that when you're finding the limit of a polynomial, you don't have to worry about indeterminate form. It just substitute the something into the something. So anywhere in the polynomial here, I see x, I'm going to substitute -1. So it becomes 2 times -1 squares minus 4 times -1 plus 2. -1 squares is 1. 1 times 2 is 2. -4 times -1 is -4, positive 4. 2 plus 4 is 6. And 6 plus 2 is 8. So this one here is 8. But remember, the question says that it is continuous.
Yeah.
The question did say to us that it's continuous. Now, if it is continuous, it means that a 1 year must be the same as a 1 year, don't it?
Exactly, sir. But how you get the A and the B?
Don't worry about it, man. Don't worry about it. So me I tell you now, say, to the right of the limit of -1, I'm going to have the function ax plus b. See it here, so ax plus b. But inside of here, so now, anywhere in the function I see x, I am going to put -1. So what I'm going to end up with now is -a plus b, because anywhere in the second function I see x, I'm going to put -1, just like I did in the top one here. So I'm going to have a -1 times a is a -a plus b. Put this down, I soon come. Then I'm going to look now at x equals +1. This can go. X equals +1. +1 to the left of +1. Where am I? To the left of +1 is the same, ax plus b. Hey, hey.
So you know me a dance right now.
Why I dance?
Has a fire, you get pure tiki.
Sure, good, nice. So me like it. This is what was it? 1 again, no? Very nice. You see, what I want you guys to do now, what is going on, Jesus, ax plus b, is we want to develop the confidence. So make you know work we do, like in class, yes or no, on homework, just try it. me not interested in you getting anything right at this stage. Just try it. All right, let me just do this and then come back to the function. I need to look at the other function now. The only trick to this question is I am going to do to the right of the function first. And to the right of the function is going to be 5x plus 7. So I am doing the right of the function first, and I'm going to get 5x plus 7. And you will see why I do it like that. And anywhere in the function I see x, I'm going to put 1. So it's 5 times 1 plus 7. And 5 times 1 is 5. Don't. Plus 7 is how much? 7 and 5, 12. Plus 7. Want to talk to me, no, man? When am I working? My phone working now?
Yes,
Yes,
sir.
sir.
So far, so
Sir, I try to talk it in.
All right. So what I'm doing here now is I'm looking to the right of negative of positive 1 and looking to the right of positive. Remember, I have to look at left and right, you know. And the truth of the matter is I always go to the left first and then the right after. Right? But there is nothing in the textbook that says you have to go to the left first and the right after. If I want, I can go to the right first and then the left after. Just make sure that I go to both left and right. All right. So look at this one here now. So I'm going to the right first in this case, and the right of it of the function is going to be 5x plus 7. Anywhere in a function I see x, I put 1. So it's 5 times 1 plus 7 is equal to 12. To the left of the function now, to the left of 1 is going to be ax plus b. It's going to be ax plus b. So ax, anywhere in the function I see x, I'm going to put 1. And it's ax plus b. So it's ax plus b. And that is going to be a plus b. Watch me now. So anywhere in the function ax plus b, I see x, I'm going to put 1. So I'm going to get a times 1 is a plus b. No, the question did say to you that the function must be continuous. It says that the function must be continuous because if it says continuous over negative infinity to positive infinity, that means that the function is continuous everywhere. So in order for the function to be continuous, this a plus b must be equal to 12. Watch this now. No. Solving the EQUATR equation. So I now have to do a simultaneous solution. I have 2 equations in 2 unknowns. I'm going to solve them simultaneously. When I solve them simultaneously, I will get the value of A and I'll get the value of B. All right. So let me just go through that before I do the simultaneous equation and solution.
I knew some simultaneous equation that go come in, you know.
Yeah, man. Yeah, man.
Figure out how to apply it.
Sorry. So basically, any question like this is going to result in a simultaneous equation, right?
Yes, but sometimes they will give sometimes they will give you. Sometimes the simultaneous equations may come out as a varied form. Yeah. Okay. Yeah. Yes, that's what Sean, right?
No, sir.
All right. Say it again. It wasn't Sean? Oh, who was that a while ago? I'm trying to differentiate the voices, so work with me. Who was that?
Christopher, sir.
Oh, that was Christopher. Okay, sorry about that, Christopher. You said Christopher? Christopher. Oh boy, you're wrong with me. Come in, have no Christopher in the first. Look back in the chat, Sean. There was a message in there that I sent for you. We'll read it again. All right. Jesus, where was I? Solving simultaneously. Solving simultaneously. Lord, how do I do this for these students? Oh, Jesus. Okay. So, come on, using the, all right, tired now, the Elimination elimination method. When you see me making so many mistakes, so you know exactly what this means, right? Bedtime. So we're using the elimination.
1 hour to go.
Thanks for that gentle reminder. All right. So we're talking about the elimination method here. So we're looking at the elimination method. So I am going to name my equations. I'm going to name my equations. And I'm going to call my equations. So I'm going to call that 1. And then I'm going to call this one 2. So when I look at equation number 1, numero uno versus numero dos. Numero uno has a negative a. Numero dos has a positive a. So to use the elimination method, I'm going to be adding both. Numero 1 y numero 2. I'm adding both equations, number 1 and number 2. So y comes is when I add these two equations together, this negative a plus this negative a automatically eliminates. Automatically. And then I'm going to have b plus b is going to be 2b. So I'm going to end up with 2b. Come on now. Copy. Work smart. Paste. Fix up. Fix up. So I'm going to end up with 2b. Bam, bam, bam. 2b's, and I'm adding both. 2b is going to be equals to 20. 2b equals 20. Sir, show me that again. I am solving the pair of equations simultaneously. But when I look at it, I'm using the elimination method. But when I look at it, I'm recognizing here that I have a negative a, and here I have a positive a. Negative a and a positive a. So when I add these two equations together, I would automatically eliminate my a's. But since I add them 2 here together, it means I'm going to have to add them 2 here together. I'm going to have to add them 2 here together. So when I add these two, I'm going to get 0. When I add b plus b, 1b plus 1b is equals to 2b, and 8 plus 12 is equals to 20. So I have 2b equals 20. Then I'm going to paste, oh crap, undo, copy, paste. Then I'm going to divide both sides by 2. So the value of my b is going to be equals to 10. So you see how we get the 10 now? Easy, 1, 2, 3. The value of my. All right. Yes, good. Get better food tomorrow. You have to go share lunch money, you know. So b is equals to 10. Very nice. I really am encouraged by this. B is equals to 10. All right. So now I get the value of b to be equals to 10. So what I'm going to do, I'm going to put this. I'm going to put b equals 10. Into another equation, into equation equation, into equation, and I use a negative one. I use equation 2 here, into equation 2, paste, into equation 2. So the question a long though, but a 10 marks sweet. So we expect.
Sir, this should be 30 marks.
I love you. So it's going to be b. I put in b equals 10 into number 2, and number 2 is a plus b. Copy. A plus b. Paste. Anywhere in b, in number 2, I see b. I'm going to put 10, and 10. So this will be a is equals to 12 minus 10. A equals 2. I love this question.
Sir,
All right.
Software, sir.
You want the software?
Yes, sir.
It need, don't talk the truth.
Yes, sir.
Yeah, man, it need bad man, trust me. My hundred and something US dollars, well worth it. So, all right. So look at this now. And as I said before, one of the reasons I opt to do the class this way. I mean, it takes. I know how to use the software, so it's easy for me to manipulate it in a Microsoft Word document. But sometimes when I really want to move faster, I have to write. But I like doing this because at least you have the notes. And that's why I send it in a PDF form so that it does not get jumbled at all. So you always have the notes in the form that I sent it. The value of A, let me go back to the question because, share. Ouch. Let me go back to the, let me go back to the question. I didn't
Sir,
finish
you
writing it.
a while ago, sir?
Say it again?
You yawned a while ago?
No, I was laughing.
He laughed.
Okay.
So that sound like a yawn, sir.
It wasn't a yawn. No, honestly, it wasn't. No, man, I laughed because I felt something like just crawling up on my foot. And I know what I would do if I saw something crawling on my foot, right? And I would have to go mute the class first because Charlene Crump will have that over my head for the rest of my life. So that's why I was laughing. No, man, no, yeah, man. Hey, we're ready. Class just started, you know. What are you talking about? All right, let's go.
I'm never reach area.
But you got it two. I should ask you. You got it two?
Yes, sir. I told you it was 2 and 10. Sir, so what me in my head is that when we get the 8 and we get the 12, we say it's supposed to be continuous. Therefore, we need to find what is going to give me 8 and what factors are going to give me 12. So I'm working to say, oh, but 10, first I had 6 and 6, but we said no, 6 and 6 can work up at the top. So I found the factors that will give me 12 and the what will give me 8, and so we get to 10.
Okay.
But
all right.
But
you
get a 5 marks.
You get a little bit more than 5, but I'm happy for the effort. Love it. Now, that's how those 10 marks come into play, All right. I'm going to stop share right here, so. Determine the values of A and B such that, okay. Why did I do that? Therefore, A is equal to 2. And B is equal to 10. Right. This comes with a lot of practice. Now, let me do this to show you what the 2017 past paper looks like. Question. So you see if I can't type right here, so. Oh, strange. So the question says the function f is defined as that. Oh Lord, but it has an unknown. It has 2 unknowns. We need to find it. But here the trick to the question. The question says to us that, listen, it is continuous from negative infinity to positive infinity. It means that anywhere along the continuum, the function is continuous. There is no point at all along that stretch where you have a point of discontinuity. It continues at every single point from negative infinity to positive infinity. So therefore, we were able, with confidence, when we found the limit to the left here and we got 8, because we know it's continuous, we got to set the second one with the unknown equals 8. So why? Continuity says them two here must be the same because it is behaving well, and them two here must be the same because it is behaving well. Now, when you have a good behaving child, very nice. When you have a child looking like we can trouble now, like Jermaine, so you have to pray every day, sackcloth and ashes to pray. All right, but what needs to happen is that, importantly, is for you to recognize that you have to set this negative a plus b equals to 8. No other number will work. Sir, why? Oh, then sir, you think you're smart, That's why they work out to the right one here first, because you need to know which one to put this one equals to. Very good. So that's why I work out the limit to the right side first in this one, so that when I work out this limit, I know exactly what to set it equals to. 12, 12. Now I'm solving these simultaneously, and when I do my simultaneous solution, I'm going to get a equals 2 and b equals 10. And that now will set my piecewise function to be a continuous one for every point from negative infinity to positive infinity.
Sir, a quick question. We can just write down. Can we just write the limit just like that without any notation?
All right, say it again, Zidane.
All right, sir, for the top one where it will have at x equal -1, sir.
Okay,
when we write the first limit to the left, yes, sir. Do we have to make a notation to state that because of continuity, the equation to the right, sorry, limit to the right is the same?
I have to tell them that because them tell me say the function continuous. So you're asking me based on what it is that I have, and I know exactly where you're going, I believe. Let me just come out of this thing, Bobby, and close. And so you're asking me, sir, I don't see right something like this, right? See? This is what you're talking about. What I don't write is to say that it's continuous right here, sir. Talk to me now, Papa.
Yes, sir.
Right.
Yes, sir.
Yeah, because the question told me that it's continuous. So I wasn't checking to see whether or not it is continuous. You notice in this case, the question says, determine if it is continuous. So because it asked me to determine if it's continuous, now I have to tell them based on what we calculate it is continuous. So this is my conclusion. But in a 1 year, it tells me, and I need to finish the question. It tells me that the function, we need to find the values of a and b, the value of a and b, so that this function is continuous over every single point from negative infinity to positive infinity. So it told me that it was continuous, but it's for me now to find the unknown. So because it told me that it's continuous, I can brave enough to put this equals 8 and this equals 8. I'm brave enough to put this equals 12 and this equals 12. Sir, why? Because the question told me that it was continuous. So I didn't have to make the statement. All right, very good question though. You are paying attention. And incidentally, that was your first question for the semester. Send them on. Very nice. All right, guys. What I will do at this point in time, as I try to keep your notes looking a little neat and consistent, what I will do, it's now 5 minutes past 9. I know this was a whole lot. I can give you a 5 minutes break while I continue with the searching the past papers. I must find me another question like this to give to you. I must find.
Sorry, you need a 5 minutes break? All right, we'll get it.
No. Oh, no. I'm fine, So if you want to run, I can go. I tell you, when I'm teaching, I get excited,
We can get it, sir.
Sir, you say you're tired, sir? Because if you're tired, no, sir, you can get a refund.
Sir, we'll get a 5 minutes break.
No, sir. No, okay, let's go. Because only take me 1 5 minutes. No, sir.
Sir, I cannot drink coconut water and wash off your
say be kind of tempted enough for go in here. So I love coconut water, but no, I drinking some room temperature water this time. What am I looking for? Oh, am I looking for? Okay, so all right, so I need to stop share right here, so now, because I am gonna go into some sensitive documents right here. So no, I don't need to share you. All right, I'm going to be finding all right, so I can get out of this. Oh Lord, I need to finish writing the question, but anyhow, you understand. 3601.
Sir, the
Yes,
same
please.
question in unedited source. Where to go like this and get the answers.
Yeah, ma'am. Yes, please.
Okay.
Same as so. All right. So guess what? Now in 2018, they never have no question. The people look nice to you. John, I'm excited. 2018 didn't have any of those, any piecewise question at all. No piecewise question for 2018. All right. Let's go to
Sir,
yes, Papa.
May 4th, 2010. Let me see. Question number 1C. I think it has the same thing.
Okay, so you assume that May 4, 2010. We not have that. We not have that. We have that? Is it there?
Yeah, I have it.
It's there.
All right, what I had to do, you see, I had to put, which is why I kind of stop share or whatever. I had to save these things to my drive because my Bembe said to me that I was running out of memory, so I had to clear the thing up from the phone. All right, do me a favor. Just send back that one in the group for me, please. So I can save it to the drive. Please and thanks. May 2010, or this is 2008. All right, let me know when you send it, Papa, please. I got a question. What is it? May who? Okay. Where's the question, guys? Don't break the momentum, man. Are you want the 5 minutes break or not? Sure, you make me feel like me want 5 minutes break or not.
Highlight the one in the group, please, so sir can have it.
Yeah, I'm not seeing. All right, let me go again. 20. That's 2008, 2007, 2007, 2009. Let me see if this one is 2009. All right. I had a. Who suggested 2005? Send a question, please. You man, this can be right. You don't get this in calculus 1. Why they put it on? No, that's calculus 2. Hold on there. Oh, I'm looking at the wrong calculus paper because I was going to say the Monday not been ready. All right. Clearly the 2005 paper is missing, or 2015 paper missing.
10, sir, 10.
Oh, it's 2010. Oh.
Sir, you really need the break, man.
And I'm at 5 me here now. All right. Can you just highlight it for me? Somebody just take it out and just reset it now, please, because I'm really not seeing it. Is it the August paper? No, that's 16. Sure. Somebody, please and thanks. Just look for the 2010 paper, please, and just reset it.
Please. I'm not see that.
I'm not seeing it. That's the point.
It's a May paper.
It's a May paper. Me not see it. All right. If you find it,
Like
just
think in the chapter.
if you find it, just you can just screenshot the, you know, if you send a whole paper if needs, you just screenshot the something and send the question, please, because I'm not seeing a 2010. All right, I look like about 5 times. Now look again. But I really want to find another one like that to give you. Let's see, 2007. Let's see what this one looks like. Come on.
Someone sent something in the group, sir.
Oh, somebody sent something? All right, come in. Thank you. Thanks. All right, great. Yeah, except though that this one don't have any unknown. So it's supposed to be less marks. All right, see? Less marks, 7 marks. All right. All right, so I appreciate it. Thank you very much for sending it. Hello, could them limits question, man? Nice. 4 and 3, 7 and 5, 12 and 3, 15. Piecewise is that 22. And this continuity function.
Too much later.
And determine the value of x for the function is discontinuous. So part 3 of the last part of that question for 3 marks in part B 3 is the next topic I want to move into, continuity, but I'm not going to be moving into continuity yet. You know, I'm sensing it that I just need to spend a little bit more time with you guys with this stuff. But for sure, come next week, I'm moving on to unit 2 here, and it will include us doing questions like determine the value of x for which g of x is discontinuous, part 3 of the question, for 3 marks. So this question 4 is, yes, on a country.
What about BI?
BI, say the conditions.
Answer that question.
BI is fine. Our BI is perfectly fine. Matter of fact, let me just show you what BI looks like.
So that means that when you're finished with this class and send the notes, you can print.
You can print now, yeah. So BI here, that's what are you seeing it now? Are you seeing it? My screen?
Yes, sir.
Right. So BI talking about continuity. So it says state the conditions for a function to be continuous at x equals a, which is a statement, the statement of condition for continuity. A function is continuous if f of a exists. And I love this. And look at what is happening also. F of a exists. The function to the right of f is going to be equals to the function to the left of x, which is going to be equals to this, the function to a. Sir, what does that say, sir? All right, watch me. I'm going to look to the right of the function. This one, they put the right first. I'm going to start with the left. They're going to look to the right of the function here, so. And the right of the function that they put right here, so, is going to be equals to the left of the function. So the right of the function equals to the left of the function. So the right of the function is equals to the left of the function, which also equals to if me just put the a into the f. See it here? And if all of them exist, then I can say f of a is going to be equal to that. That means this piece is going to be equal to this here piece right there. So, and it does. So these are the three conditions for continuity, right? As I said before, so you may have it here so for you already in the stuff. The question in part 3 that you're looking at right there, so is a question that looks similar to this. Find the values of x for which bam 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 is this continuous or undefined. I have these here sorted out for you. For the continuity is not a long topic. Chances are I may be able to finish continuity in a week. All right. So yeah, man. So you don't have to worry. They're right here. So all right, do me a favor. Do me a favor. I want you to go and work. Sorry. Which year is this? This is a 2010 paper, right? I just want to make a notation. 2010 question 4. I want you to work part B2 for me, please, guys.
Sir, they actually sent the actual question. It was sent after this one.
Oh.
It looks very similar to the one that we did not too long.
Oh, great. Great. The limit of a constant is the?
Constant itself.
Very good. I'm going to say it one more time. I repeat for me, please. The limit of a constant is the?
Constant itself.
Very good. Always remember that. So when you're out of the blue, you just come talk about the limit of a constant is a constant itself. Because I look at the function and I recognize that you have two constants there. All right? 2 and -2. So the limit of a function, the limit of a constant, I'm sorry, is the constant itself. Do me a favor. I'm giving you, this one is easier. This is supposed to be less marks. Yeah, 6 marks. This is much easier. Thank you for sending this question. I'm going to see if I can type it and do it myself now. On a mark, gets it, go. Start working for me, please. And thanks. Sorry, somebody help me out. This is what year? This is December 2010 or January 20. What year is this, please? Copy. Please.
2017.
That was a 2017 paper? No?
Oh, no, I don't know.
All right, I'm going to put 2010 on here. Somebody just said 2010. All right, start for me, please. I have work, you have work.
What is a real line, sir?
Real line? I don't know. Where's it?
In the question.
Oh, find the, okay, yeah, man, it has to be a line. Find the constants a and b so that the function is continuous on the entire real line. It's because you have all linear functions. Linear functions are straight line functions, right? So the highest power in the function is raised to 1. All right, let me just talk about that because it's important. Thanks for answering the question. Can you just allow me to just type this question before I go? -1 and less than 3. You see, past papers come in nice because maybe me, I think we'll write them something here.
Pass maths.
Say it again.
Pass papers, maybe pass maths 6.
So, yeah. Past paper says me when I was going to university. Real talk. Save me lives. All right, good. Second. So when this form chips out, now I don't have to worry. All right. No, so what is happening here? This function is not a straight line. This is a curve. Oh, you know, sir, because of the x squared. This one is a straight line. This one is a straight line. So when I'm plotting this graph, piece of this graph will have a curve to it. So let me just show you something here. I'm not going to sketch it now. I did say that I was going to do sketching, but here I may have a little curve going somewhere here, so, and then the other one I'm going to have a straight line, and then I may have another straight line. So when I plot this, you'll see exactly what I'm talking about. So this one here is a curve. A curve is right here, so. Let us go up here, so. This one is a straight line. This is not a straight line, right? This is not a straight line. Straight line, straight line. Straight line, curve, straight line. Straight line, straight line. So the point is, it says continuous straight line because into say x equals 2 is a straight line, x equals -2 is a straight line, and ax plus b is in the form y equals mx plus c, which is the equation of a straight line. So all of these are straight lines. So that's why it says straight line. Make sense?
Yes, sir.
Good. Start for me, please. Aviana, I feel like you're in malice with me. You don't talk to me from night. Well, go on.
Sir, I'm fine.
No, mommy, I kind of feel left out. You know, talk to teacher, man. All right. I'm happy that you're okay. Who don't talk to me? Awfully, you talk to teacher since night?
Couple times, sir.
All right, good. All right, nice. Shano, good night. Keriko, good night. Shani, good night.
Sir, good night, sir.
Right. You must talk to teacher night time, you know. You can't just come to class. Dave, you're unmute for me, please, Dave.
Sir?
You talk to me since night?
Yes, sir.
All right, then cool. I forgive you. Yeah, all right, then cool. All right, start working to you. I just did a quick thing now. Anybody finish? All right, continue
Yes,
work.
sir.
You finish, Yanni?
Yes, sir.
What do you got for A?
A, I got -1. B, I got 1.
Okay. Anybody else?
So I'm fine B, but I'm back again. So
What do you get for B?
-4.
-4. All right, let us take our time and I mean, this can be the last question. Well, it will be the last question we're doing tonight. I want you to take your time and just go through the question. You need tell me to look over the question again for me, please. I'm going to do the same thing for me.
Sir?
Yeah, man, I was just about to ask somebody else to come in. Yeah, let me hear you. Go ahead.
Sir, I could be wrong, but
Oh, sorry. Go on. Tell me.
alright. I have A equals 0 and B equals -2.
And because negative 2. All right, no problem. I think your problem, not yours alone, but the rest that I've heard from also, is with the simultaneous equations. And I'm praying to God that I don't have a simultaneous equation problem, because I don't want to be having to teach simultaneous equations. That's a little school something, you know. Try and make sure that I make it. I have double checked 9. I still can make a mistake somewhere, but I'm
Alright, so
not
that
getting.
means I need to look over mine then.
Yeah, man, I'm not getting the answers that you are getting. You all are getting. Oh, hold on, hold on, hold on, because your teacher never look at that negative sign. So you hold on. Sash, where say you for the answer, Sash?
A equals 0 and B equals negative 2.
Oh, no, that's not what I got. But I was I just found an error on 9. I was wondering why I was giving that to me, but I thought they were just being very creative in giving me that answer. All right. Sasha, we answer to see it again. A equals what?
A equals 0, B equals negative 2.
Oh, that's not what I get. All right. Let us go. By the way, let me just give another person another opportunity to tell me what it is that you got. Somebody, please, somebody else, please. Tell teacher what it is that you have for your answer. All right. You know what? Let me call upon somebody. Somebody, anybody, somebody.
Sir, I got A equal to B equal 4.
Okay, thanks for your suggestion. Still actually doing about thanks for your suggestion. Jermaine, newbie, unmute for me, please.
Yes, sir.
What did you get for the answer?
-1 and 4.
What is -1, Jermaine?
A.
And -1 is A. And 4, you get 4 to be the other one. Can you double check? Can you double check B for me, please, Jermaine?
Okay.
Sir, all you know to be 0 and negative 2, sir.
I soon show you, man. Fret not. Lexton, what me not understand, Lexton? Lexton gone in bed, you know?
No, sir,
No.
I work out, sir.
Lexton, no man. You sleep away. You sleep and wake up, Lexton. You
No,
from
man,
you ask
sir.
a long question about 7 o'clock, Lexton. You don't answer not. You don't ask nothing more, Lexton.
Me nah follow through. I follow through, you know, sir.
Oh, you're understanding.
Yes, sir. Remember, sir,
Sure, you know?
I believe I help you with the first one, you do.
Sir, we can vouch for him. Him never gonna sleep. If him did not sleep and you call him a while ago, you would get an answer.
I boom, me have to drink for that class tonight, you know, sir.
Oh, goodness, you see? And then when I go get drunk and I go blame me, no.
Sir,
That is my
boom na drunk, man, sir.
I
Boom
lie
just
you
a
tell.
make you.
I want to say I drink one spurn up. I think you more 12 hours sleep. And it wasn't a full bottle of Smirnoff Ice. I couldn't go to full bottle.
Sir, Smirnoff Ice na drink na joke nobody.
Okay.
A baby thinks that.
Would I drop program if we drink?
Sash, talk truth.
A 6 me drink.
What? Tell Peter you are a rumhead. You are a rumid.
Kelvita, you have the body to stand up to it here.
No, man. 6. Jesus, man, I have to pronounce my over funeral for that. All right. Karika. What do you get, funny bunches? Well, German was close, but I don't know what it is that he did wrong.
So that means for me right then.
Sir.
Which was the first answer you got?
No. Lambert, what do you say?
Not sure if I'm correct.
Go ahead.
Not sure if I'm correct, but I got A and B to equal -1.
All right. So you and German should have a conversation because piece of yours right, piece of one right.
Sir, B is 1.
And A is?
-1. I said this from the start of the class, sir.
Did you say that for true?
From the start of the class. That's the first answer you get. You can put over my answer because your answer wrong.
Yannick, go to bed. Yannick, leave my class and go to bed.
Right then.
You know, Yannick, go to bed.
Sir,
Gentle Jesus, be kind, look up on this child. Go to bed. Yes, Yannick, you're correct. I'm gonna buy you something very nice. You're correct, Yannick.
Sir, I don't eat shrimp, I don't eat lobster, I don't eat any pork, I don't eat, none of those things, sir.
No problem, I can just buy a dirty girl.
A what? Of course, sir, of course. But you have to buy a pound of rice too. You have to buy a pound of rice too, sir.
Sir, please show me all that get right, please, sir, please.
Very good, Yanni Boo. Proud of you, Yanni Boo. Proud of you, Yanni Boo. All right, let me just put all of this into. All right. Look at my solutions. Let me know when to. Oh, you know what? Sorry. Let me just. Sorry, that's not the question, don't. All right, there you go. Sorry, let me just project all the question, all the parts. Sorry. Let me just do this. And yeah, now you're seeing it. Good. Very good again, Unique. I'm really very proud of you. You're not allowed to get any other questions that I'll be doing wrong. And for those of you who made some mistakes, you know, look at it and then you can question me accordingly.
Sir,
yes,
drop the question back on that page there.
And I know, hold on, let me see, do I have a question? Let me just close here. Yes, I do. There you go. Very nice. Jermaine, you see where you go wrong now, Papa?
Yeah, man.
All right, and Ramesh, you see where you went wrong, folks?
Yes, sir.
All right, cool. Very nice. And that's fine. That's fine. Now, while you are all looking at it, I'm just going to be responding to a message. Now, one of the things that I want you all to learn. I remember when I was going to school, for sure, when I was doing A-level math, I had some people in the class, them bright. Jesus, Father. I used to afraid to go to math class because them just bright. And the truth of the matter is, sometimes the teacher is teaching them a topic, like the teacher teaching this, and then get it the first time the teacher do it, them get it. And the teacher put 100% on the board and they get the 100% right. And I am there flipping my page back and forth and how do this, how do that? And they were just bright amazed. Now, you know what I had to do in order to keep up with them in class? Me know so when I'm coming, they not study now because they're just naturally bright. When me go home, me have to go study 5 and 6 hours so that when I come to the next maths class, I can be on top of things. Now, one of the things I'm going to tell you is that by the next maths class, everything that was done the previous math class, me learn it. It took me a longer time to learn it, but me learn it. And when I beat up them face in the class, and teacher said, and you, Shand, say, yeah, man. Say, me say, go, sir. And I said, wait, the boy never leave. But I wasn't in the league, because they be well bright. Well bright. But the truth of the matter is, and this is what I'm saying to you as I read one of a private message just now. You may not be following what is happening. I may hear other students in the class getting the answer. Be happy for them. It only suggests that you now need to go and put in 2 times, 3 times as much in order to be on top of things. 3 times as much. The other thing that I say as I'm wrapping, trust me, I'm being very gentle with you guys, very gentle. And as I said before, I could have gone on to my unit 2 and say, all right, we finished unit 1, moving on. But that's not my style. I want to make sure that when you're moving with me. But guess what? I'm not going to be able to sit and wait on some of you who will be dragging your feet. So you have to get up, start working, and do some stuff, which segues me now into a bit of housekeeping. A few of you have logged on to Ericasoft, and quite a number of you in the class have not done anything. I saw one key person. Sorry, I going to tell you who it is. I saw that question in the chat, and I just never got around to do it. Krishna is not yet added, and I saw where Charlene instructed him to what to do. Students, it's time now for you to read through your tutorials just to get a different perspective. Attempt the assessments. You should be able to attempt the assessments now because I've gone through all of those with you. I need to see some assessments covering. All right. So
one in the expire now.
Yes, because I was hoping, I saw that today also. I was hoping that my students would have gone through. So the first 3 are expired. I will reopen those because not one Jackman or woman did those. So I'll reopen those a little later on when I sleep and wake.
Tutorials first.
Very nice. Yeah, man, I saw that. I saw that some of you have been going through, but for the most part, I need to see a little bit more activity. All right. So are there any questions? Anybody want me to just, I'm going to send this off. Oh, Lord. All right, let me just type the question. I'm just going to finish the 2 questions. The 2 questions, the 2 last questions we did, I'm just going to finish the past paper so at least you can see what it is that the questions are saying. And then I'm going to send off this document tonight because I know 1 or 2 people are a little uncomfortable and I want they may be able to sit up a little longer than me. So I'm going to give them an opportunity to go through this document. So I'm going to just, after class, type up this something, send it off, so it is that you can have it to review. Are there any questions? Any other questions for me?
Sir, for
Yes,
your
please.
3, I see you have negative 3 plus 3b plus.
Yes, sir. Where you get that equation from, sir?
Okay, so I'm solving simultaneously, and all right, I'm gonna change my view, please. Sorry. I don't have the flexibility that I want. So I ended up with these. So do you agree with these two equations? Negative a plus b equals 2 and 3a plus b equals negative 2?
Yes, sir.
All right, good. So I'm solving simultaneously. So I want to eliminate my a's. So because I want to eliminate my a's, I will have to multiply the first equation by 3 so that I can get this here to be negative 3a and this here to be positive 3a. So when I add them, I get 0. So when what I'm going to be doing, I'm going to be multiplying equation 1 by a scalar quantity 3. It will not change the value of my answer. It will not change my result. So I'm just going to go ahead and multiply throughout the equation. It has to be throughout. So I'm going to multiply 3 by negative a. I'm going to get negative 3a. 3 times b, I'm going to get positive 3b, and 3 times, so I'm going to get 6. So I have actually increased this by a scalar quantity 3 so that I'm able to add these two. Negative 3a plus 3 goes to 0, and then I'm able to eliminate my a's and just work with 3b and b. 3b plus b is going to be 4b. And the mistake that I made was to say 6 plus 2 is 8. So I got b to be equal to 2. But it's when I look over, I said, no, but this is negative 2. And it's because I copy and paste, but anyhow. So it's 6 minus 2. I'm adding these two. All right, so 6 plus minus 2 is going to be positive 4. 4b equals 4. B is equals 2. Divide both sides by 4. B equals 1. And then I'm going to put b equals 1 into equation 2. Sir, why equation 2? I'm going to put it in 1 or 3, any equation I want to put it in. But I chose 2. So it's going to be 3a, and b is 1. So it's going to be 3a times 1. I mean, 3a plus 1 is equals to negative 2. And when I subtract 1 from both sides, I'm going to end up with negative 2 minus 1, which is negative 3. And 3 divided by negative 3 is going to be equals to negative 1. So a is 1 and b is negative 1. A is negative 1 and b is positive 1.
So,
and
sir,
that's all. This one.
basically, you said for the scalar thing, you use the same 3 with b.
Which 3 talking about?
But up by 2, so you can get 3.
Yeah. So what I did, Sash, was to look to see what number is in front of this here. So had this been a 5, I would have multiplied through this equation by 5. Any number is in front, whatever number is in front of this a right here, that's the number I'm going to multiply through by the first equation, so that so one becomes the additive inverse of the other.
So you can cancel it out.
Very good.
Okay.
Sir, so couldn't you have just subtracted to cancel?
I could have also subtracted, because since both b's are positive, if I subtracted, I would have gotten b first. I could have.
But you just like to go for a first. Cancel a.
Not necessarily. It's just that a was just right out there to my face, but it could also do b. So remember, no, yeah. So you could also do b. Yeah. All right, guys. Just how was tonight?
Full, sir. Full.
Full. Yeah, man. Anybody else?
Sir, question.
Go ahead, Kevita.
In equation, that means that if you're solving for A, whatever if you're solving for B, whatever is in equation 1 and in equation 2, the A's must have the same number or the same, they must be
Value.
equal, same value, but one must be negative and one must be positive.
Or just like what
Sir, that is why
Honey.
I asked the question. I didn't know, because I know persons may be thinking you need only to add. That is why I brought
right. So what right. So what all right, you know what I'm gonna do? I'm gonna do the question another way, eliminating the B's first. Eliminating the B's first. I really wanted to give you this document tonight to know, but METHOD method 2. B's first. All right, so I'm going to eliminate the B's first and send it out so you can look at both methods. All right. What this is saying to me is a simultaneous issue, but METHOD method 1. Eliminating the A's first. All right, not a problem. I will definitely do this to get this up. All right, I'm going to end here. Hearing people leaving, and I know people are a little tired. Oh, sorry, it was the saving. I know people are
before
tired.
you end, can you say something that might make what Kelvita asking a bit more clear?
Yes, that's what I'm going to do for method 2, in terms of the subtraction.
No, it's just a general statement that
you want to say something?
Yeah.
Okay, go ahead, hon. Go ahead. Sorry.
All right. So the aim is to get one of the terms, either A or B, to have the same value in front of it and then eliminate it. So elimination may be done by subtraction in the case of A, because in the case of B, where they're both positive, so subtraction would cause them to become 0. While in the case of A, because one is negative and one is positive, addition would cause it to become 0. So the aim is to get them in the same value and then use either subtraction or addition to eliminate the term.
Yeah, very good. Now, there's a little saying, I may put it there in the document too. There's a little saying to say that when the signs are the same, you subtract. When the signs are different, you add. So here, the signs are different. So I ended up adding. The signs are different. So I ended up adding. Okay, so this is tired. EQUATI. So I'm adding both equations. Let me cut this. Cut. Backpaste. Solving the equation simultaneously using the elimination method. All right. All right. So when the signs are the same, I add. Rubbish. When the signs are different, I add. When the signs are the same, I subtract. But I will show you, I will do that, and then we can have a further conversation here. But thanks, Yoni, for bringing that point out, and you do the stuff. All right, guys, it's 10:01. You've been a good bunch of students. Really appreciate your time, your energy, your effort, your contribution. Please do what it is that you need to do for me. All right, have a good one. Sit tight.
Bye, sir.
Thanks, sir.
Yeah, man, easy.
Bye, sir.
Okay.
All right, sir.
Yeah, man, easy, Papa.
Bye, sir.
Bye.